institution subject to inspection and supervision by the Ministry of Education.
Good morning. Let me introduce myself. My name is Jose Murillo Saavedra, together with my colleague Juan Camilo Arocha, and today we are here to present our project called Smart Cane for visually impaired people. At this moment, I am here to present the introduction and justification of the problem of global and national magnitude. To begin, visual impairment affects more than 2.2 million people in the world and more than 1.1 million in Colombia, where 43% are over 60 years old, and in Cundinamarca, it is one of the most affected regions. The problem in Girardot. There is a serious exclusion in the infrastructure. Less than 5% of the roads have tactile signage or adequate ramps. In the technological gap and connectivity, the INSEE reports that only 12% of this population accesses assistive technologies due to their high costs. Moreover, the Ministry of Information Technologies and Communications states that 38% of rural areas have less than 20% internet coverage, making conventional mobile applications unfeasible. The consequences: constant exposure to accidents, dependence on others for basic activities, or exclusion from the educational and labor system. For the background, it would be the description in health. Inaccessible technology. It is supposed to be a low-cost prototype developed with an Arduino and an ultrasonic sensor HCCR04 operating 100% offline. That is, it does not have to be online. It does not require internet connectivity or GPS signaling to operate, solving the lack of network in the rural sector. Alert mechanisms are the sensors that detect obstacles on the path and notify the user through audio or vibration signals. The intensity varies according to the proximity of the object, sustainability, and the legal framework. The project is economically viable, aligning with Sustainable Development Goal 10, which is the reduction of inequalities, and Sustainable Development Goal 11, which are inclusive cities. And it is supported by Law 1346 of 2019.
Well, as the third point, we have the general project objective, which is to design and implement a cane with an ultrasonic sensor to optimize autonomous mobility in urban and rural communities in Girardot. A specific goal is to make the prototype with locally sourced materials, which ensures a cost of less than 50,000 Colombian pesos. Ideally, it would also be to evaluate the sensor's performance in real environments, such as houses or in different places, like indoors and or outdoors, which would be like the streets, the city, and so on, more or less. What we are going to do is document the process to ensure that the replica is a community version of the device. Well, as the fourth point, we have the evolution of technology, which is what drives AI, that is artificial intelligence, to transform the cane from a mere detector to an adaptive system that works without connection to external servers. What is proposed is to have 4 modules that implement embedded AI, TinyML in short. Small ultrasonic models executed directly on the hardware. Using tools like edge impulse to classify types of obstacles such as walls, poles, or people, and recognize the surface as cement, soil, or water. A natural language process is NLP, which is a bidirectional audio module that allows the user to interact verbally with the device. For example, asking or stating distances or activating different modes. Adaptive learning has an algorithm to memorize the user's frequent routes, such as anticipating areas of some event or personalizing alerts according to their walking speed. Computer vision is like Bluetooth connectivity to a mid-range or low-end cell phone so that the camera can recognize different faces or signals that may be on different roads, describing the environments with the user's voice.
Institution subject to inspection and supervision by the Ministry of Education.